Hello, BC Calculus students. This is Mr. Johnson, and this is section 3.2, which is on the product and quotient rules. Two rules that you know really well from last year, so this should be a real easy, pretty quick section. So for the product rule, and I know that sometimes depending on who you had last year for AB Calculus, might have taught it a little bit differently. I always teach it as the derivative of the first times the second plus the first times the derivative of the second. I know a number of people teach it as the first function multiplied by the derivative of the second plus the derivative of the first times the second. And obviously, that's totally fine either way because of addition, commutative property of addition. So you can rearrange that, no big deal. With division, you have a quotient rule. You want to make sure the order stands because the order is really important here. So if you're going to take the derivative of h given f divided by g, we have the low function multiplied by the derivative of the high function minus the high function multiplied by the derivative of the low function divided by that low function squared. And again, the order is really important because of the subtraction. Okay, let's try a couple of these. So with the first problem, we're going to find the slope of the tangent line to the graph of y when x is 1. So this is going to be the quotient rule. So when we do y prime, we have the low function multiplied by the derivative of the high one minus the high one multiplied by the derivative of the low function divided by the low function squared. You can certainly simplify this if you'd like. What I'm going to do is just plug in x is equal to 1 right now. So we have, let's see, this can be 2 times 2 minus negative 1 times 2 divided by, and I'm realizing that I missed a square here, I apologize. Change that in your notes so that there's a square down in the denominator in the red that I hope I said, but I didn't write down. So that's going to be 1 plus 1 squared, so that's going to be 4. So that's going to give us, let's see, 4 plus 2. So we have 6 here over 4, so we get option E, which is going to be 3/2. Okay, let's try example 4. This is going to be another quotient rule. So we have the derivative equal to the low function multiplied by the derivative of the high function minus the high function multiplied by the derivative of the low function divided by the low function squared. I'll make sure to remember it this time. And then obviously that answer is not the exact way that they're showing it in the problem. So we need to simplify this a little bit. So we have x squared plus 1 minus 2x squared minus 2x. Looks like all we can do with simplifying is just combine the x squared. So we have negative x squared minus 2x plus 1 divided by x plus 1 squared, excuse me, x squared plus 1 squared, and that looks like it is option C. Okay, let's go on to page number 4 in your notes. All right, in this problem, we'll do a little bit of review. The first part, we're going to do an odd versus an even function. So remember, when you're trying to show whether or not a function is either even or odd, you always start with f of negative x, and you substitute that in for every single x value in the problem, which looks like this. All right, so negative x, can't do much with that. Sine of negative x is going to be negative sine of positive x. And the reason for that is that sine is an odd function. We talked about that not too long ago. Cosine of negative x is equal to cosine of positive x, and that's because cosine is an even function, which again we haven't talked about too long ago now. Now what I'm going to do right now, it does not look like the original, and so I'm going to factor out a negative, and I'm factoring it out of the numerator. And what we happen to get is the original function inside of the parentheses here, which means that what we've gotten as a result from our work is the opposite of f of x. So if you look at our logical progression through, we have f of negative x, and as we manipulate our problem, we end up getting negative f of x, and that is the definition of an odd function. So we could say that given our situation, given our evidence here, f of x is odd. Okay, now let's go ahead and find the derivative of f of x. And we're going to use the quotient rule here. So we have the derivative of f of x equal to the low function multiplied by the derivative of the high function minus the high function times the derivative of the low function divided by the low function squared. All right, let's work on simplifying this a little bit. So we end up getting cosine of x plus cosine squared x plus x sine of x plus sine squared x. All right, if you remember back to your trig identities, cosine squared plus sine squared is equal to 1. So if we were to take these two and add them up, we would get 1, which means that we have 1 plus cosine x plus x sine x divided by cosine squared. And I think that's about as far as we can simplify that one. So there's your derivative. And in part C, what we'll do is we'll write the equation of the tangent line for the graph of f when x is 0. So for our tangent line, we definitely need a slope, which means we have 1 plus, let's see, cosine of 0 is 1, and 0 times sine of x when x is 0 is 0. And then, of course, the denominator is 1. So we end up getting a slope of 2. We also need the y value when x is 0. So that's going to be equal to the, let's see, here's the function f of x. So we have f of 0, which is going to be 0 divided by 1, which is just 0. So that's our y value. So we have, again, we have a slope of 2. We have a point at, it's not very entertaining, it's just 0, 0. So our equation then is going to be y minus 0 equal to 2 times x minus 0, which is just y equal to 2x. And that's our tangent line when x is 0. Okay, that's it for section 3.2. Thanks.